Speaking of scientists, we have one rock star guest who is joining me today. We have Dorukhan Ardağ, who is the lead research scientist at Goddard Space Flight Center. Daruk, first of all, I just wanted to thank you so much for taking time out of your very busy schedule to talk with me today. How are you doing today?
Great. The spring is here finally after a really long winter, so I'm really excited.
Absolutely. It's good that we're enjoying some of the warm temperatures, right? I'm definitely with you on that. So, and I think as we can all agree, it is a great day at SSAI. Am I correct?
Definitely. Definitely.
Awesome. Very good. Well, Daruk, what I'm going to do now is I'm going to ask you a couple of questions in relation to your work that you currently do at SSAI. And my very first question I wanted to ask you was, can you please tell the audience about yourself and describe some of the projects you have worked on at SSAI?
Yeah, sure. Let me talk about my background. I was born in Turkey, grew up in Istanbul, and I went to college in Istanbul, Turkey. I studied civil engineering, and during my senior year of college, there was a professor from University of Florida who visited and gave a speech on Hurricane Katrina. So that was my first exposure to earth sciences, and that was really interesting to me. And then I applied for a master's position at University of North Florida in Jacksonville, and I studied coastal engineering there. And I focused on surface gravity wave modeling. And during my master's program, we conducted a study post Hurricane Matthew in 2016, where we looked at the aftermath of the hurricane, that done some modeling studies, and I witnessed the destruction of the hurricane firsthand. And that led me to do my PhD in coastal and oceanographic engineering in the University of Florida, again on surface gravity wave modeling and coupled modeling. And following that, I started a position in Oregon State University as a postdoc in data assimilation. We in the project there, we were utilizing data sources from multiple different types, including radar, altimetry, tagged marine birds, which was the main focus of the project, and drifters, which are on the ocean surface. Using that data, we used to estimate the bathymetry of the Columbia River estuary between Oregon and Washington states. Also, I worked on another project there. We received funding from Oregon Sea Grant to monitor the evaluation of the mixed sand cobble beaches along the Oregon coast. And after that, I applied for a position at Global Modeling and Assimilation Office, and I was hired by SSAI as a senior research scientist. And that project entails coupled data assimilation with a particular focus on the marine interface. What I mean by marine is ocean, sea ice, waves, and biogeochemical modeling.
Wow, that's absolutely incredible, Daruk. You've had quite a background, and I really appreciate you diving deeper in terms of your educational experiences and also how you came from Turkey to the United States. That's wonderful to hear. And you mentioned about a couple of hurricanes. I remember Hurricane Katrina. I was 8 years old at the time, so it was a while ago, but it was such a devastating hurricane. So, but I do remember the help that was provided there. So, in terms of your research and your work, it's just very fascinating. And again, I really appreciate you highlighting more about yourself and the work that you currently do at SSAI. And transitioning to my next question. You spoke a little bit about your work with the Global Modeling and Assimilation Office. And my next question is, How does SSAI's expertise in developing and maintaining the Swell workflow for the JEDI-GEOS coupled DA system contribute to advancements in Earth system modeling and data assimilation?
Yeah, that is a great question. Let me break down some of the concepts we are using here. First of all, starting with data assimilation. Data assimilation entails combining models with observations, and models inherently have issues that could be related to representation of the physics, or for global modeling, it could be due to the low horizontal resolution, and combining models with the observations improves the states that they're representing. The coupled data assimilation aspect of it brings in multiple types of Earth system models. For GMEO, these are atmosphere, ocean, sea ice, land, biogeochemical. So as you can see, there's a lot of models that GEOS and GMEO is capable of using. And JEDI is the which stands for Joint Effort for Data Assimilation Integration, is a product of a consortium that combines NOAA, NASA, Navy, Air Force, and it's a unified data framework. It's a software package. It is meant to be a model agnostic interface for data assimilation algorithms to be used in different types of modeling applications. So as you already mentioned, the project I work on is developing a workflow that brings in GEOS and JEDI together. And the name of the workflow is Swell, which stands for Swell Workflow Ecosystem Layout and Launcher. In terms of expertise, of course, SSAI has a lot of scientists that are working on different aspects of the modeling and data assimilation aspects of it. So for this entails observations, which for different Earth system components, there are lots of different instruments from satellites to in situ data. For conventional data, for in situ data for the ocean, it could be cargo floats, it could be gliders, or it could be even unconventional approaches such as fishing vessels or tagged marine mammals. And of course, we're dealing with, when we're talking about coupled data assimilation, we're talking about millions of data points. So this handling quality control of this data, SSAI has significant expertise in this area with multiple researchers. On the modeling side, GEOS, GMEO's global circulation model, is a very sophisticated model, and the coupling of different models is a complicated concept, which consists of different grid types for different types of models, interacting outputs with each other, different time steps. And again, we've been supporting, as I said, SSAI, GMEO for such a long time. And finally, in terms of data assimilation, we have a lot of expertise in that area. And we are able to I'm not just talking the existing expertise, but we are continuously expanding by introducing new observation types. It could be NASA missions like SWOT or PACE, or it could be including new methods that are introduced into JEDI Unified Framework. So we're positioned really well here to conduct this type of, it's a very, very complicated interdisciplinary work. As you can tell, I'm talking about a lot of different concepts here. So
Wow, that's very fascinating, Daruk, and I really appreciate you helping to break this down for our audience, because there were a couple things that I didn't even know what JEDI even stood for. So I definitely learned something new with that, and just to highlight the work that SSAI is doing in terms of looking at data, millions of data, and trying to best organize it into this research and contributing it in many different ways. employees, that's just very impactful, and that's very motivational. So I really appreciate you breaking down even further some of these main important topics, because like you said, it's definitely a lot, and there's a lot to gather from that. So I thought that was very well said there. And transitioning, Daruk, into my next question that I wanted to ask you, you spoke a lot about your expertise in developing and maintaining the Swell workflow for the JEDI-GEOS coupled DA system. But my next question is, what are some of the biggest challenges you and your team have faced in developing and maintaining the Swell workflow, and how have you worked to overcome them?
Yeah, that is another great question. The biggest challenge is the success of GMEO. GMEO puts out a wide catalog of products ranging from weather forecast, reanalysis, seasonal forecast, composition forecast, and change itself is really, really hard. When we are introducing a new system and asking people to adapt to this new system, we have to make sure we are definitely reaching to that same standard that everyone is used to, because there are a lot of agencies, scientists, universities that are using our products, our outputs to make decisions or produce scientific works. And that means to overcome this challenge, what me and my team does is we meet with people, scientists who are producing these products, and identify what are the needs for in a new system. We have to understand so we could include this into the workflow, into the software, so we can test these in our workflows. Another thing I will mention is, because our office has been putting out these products for a long time, there are some code bases that are more than 10 years old. So this falls under the legacy code, and it is sometimes challenge to use legacy code in a new and modern workflow system, because some of these software could be using older software languages like Perl or Fortran. However, we need to, especially like I mentioned, when we are bringing young software developers or young scientists, they could be not familiar with these old languages. So we have to adapt these programs in our new system. So we can either try to upgrade the existing code bases, which is not always straightforward. There could be some codes that were developed by someone 15 years ago and it's not maintained anymore. If that's the case, if we can directly upgrade them, we can run them within our code base as sub-processes in a containerized environment. And another challenge, of course, with introducing something new is we have to continuously test it. So we use modern software practices like continuous integration in the Swell workflow, which means using GitHub to conduct some automated tests as we are updating the version of the software, or if there are updates from the GEOS model side or updates from the JEDI development side, because these are very, very dynamic software packages and they're continuously being improved. So the design idea of Swell is an object-oriented programming, which really allows of changing whenever we need to update things or add different scripts, different tasks, different workflows. This really allows us to do this. So it is a big change, but it simplifies adapting to the change as well.
Wow, that's truly incredible, Daruk. And again, I really appreciate you highlighting some of the challenges you faced. And that's interesting that you mentioned that sometimes the codes need to be updated, especially if they haven't really been updated, for the last 10 to 15 years or so. So, yeah, definitely with our ever-changing technology that we have, our landscape over the last several years, there's definitely opportunities that you need to take in order to keep things, updated. So I, just as a side note, I have a very basic coding knowledge. I have some knowledge of it. So, but it's definitely very fascinating to hear about different ways that you're able to cope with these challenges and definitely testing it out. That's very key and that's very important too. So I really appreciate you, Daruk, talking further about that. And Daruk, then transitioning on to my final question that I wanted to ask you. You spoke a lot about the Swell workflow, and this is a fun question, just as a side note. But the question is, if you could give the Swell workflow a personality or superpower, what would that be and why?
Right. Personality or superpower? I can think of two major things that popped into my head. The first one is, of course, every programmer will relate to me here, but I wish when we're developing code, it was magically always bug free, so we wouldn't have to spend time trying to debug code. That would be fascinating. The second thing, I think, related to the previous question and change, the documentation is a really critical aspect of software development. So we try to keep as well documentation. So when we introduce workflow to the new users, they can go in and look at the outputs or the tutorials and test code themselves. And of course, among other responsibilities, documentation is really important, but I wish there was the Swell workflow had the superpower to automatically generate these documentation itself. So that would be great. Then we wouldn't have to keep up with the version of the code, try to go into document, find out every small level of changes went in. That would be that would be a really fantastic superpower. And of course, another one would be there's a lot of scientific advancements, scientific and especially in software world, really significant developments quickly. I wish Swell could adapt to that automatically without with automatically just ingesting all that knowledge. So I think I gave you three superpowers. I'm a bit cheating there, but I hope that's fine.
No, I thought that was great, Daruk. You went further in depth with that. So I think that was very well said. And I appreciate you explaining why with each of those superpowers. So that's definitely great. And, with, again, these continued technological advancements that you and your team will definitely make, you might be able to discover how to implement these superpowers even further. So we're definitely very excited to see some of the continued research with that. And with that, Daruk, like I said, I just wanted to thank you so much again for taking time out of your very busy schedule to talk with me today. Your work is truly fantastic, and you are, again, a rock star who is really making an impact and a difference globally. And everybody around the world is going to continue to be fascinated by the great work that you and your team are doing. Please definitely keep us informed about some continued advancements with the Swell workflow and with the JEDI-GEOS couple DA system, and we cannot wait to highlight it.
It'll certainly do. Thank you.